Greetings and welcome, friends. Mr. Wada here, talking about section 3.3, and I realize this says 3.5 up here, but that's the theorem number, not the section number. We're talking about proofs with parallel lines. Yesterday, we talked about starting with lines being parallel and proving things about their angles. Today, we are conversing yesterday's lesson, and we are starting with relationships between angles and attempting to prove the lines are parallel. So here we got the corresponding angles converse, aptly named, and it says this: if two lines are cut by a transversal, so the corresponding angles are congruent, notice the hypothesis and conclusion were swapped, hence converse, then the lines are parallel. So if I know corresponding angles are congruent, I know the lines will be all the parallels, right? So good stuff, good stuff. So you're going to now have to pay attention to whether or not you started with parallel lines and are proving things about angles, or are starting with information about angles and are attempting to prove lines parallel. So here it says, using the corresponding angles converse. Find the value of x that makes parallel to There we go. So these angles are in corresponding positions. If they were congruent to one another, I would know that these lines are parallel. So how would I relate those two measures in being congruent? Well, by def of Kong, I could say that their measures are equal. So 3x plus 5 equals 65. And we will just solve for the variable, isolate it, friends, using inverse operations in reverse PEMDAS order. Sad method. We're diffusing this algebraic bomb in the reverse order that it was assembled. So 3 was being multiplied by x, then it was added by 5, so reverse order, subtract 5. Here we go. Uh-oh, guys, diffusing the bomb. Div 3, both sides. X equals 20. Bam. And when x is equal to 20, that would be the one value of x that makes these equations, or these angles measures equal, which makes these angles congruent, and them being corresponding angles would make the lines parallel. All right, so far, I mean, this particular application does not seem that different than some of the things that we've done before. All right, let's see. Let's skip on down to some other things, other properties here. Other properties. And as you can probably guess, all of the other theorems that we learned yesterday also have their appropriate converses. Good times, good times. Wow. Guys, I love this. We're getting into the meat of geometry finally. Delicious, juicy meat of geometry. Here we go. All right, let's see. Line it up. Line them up. There we go. So, alternate interior angles. I need like the record scratch sound effect. Like, you know, it's not a theorem, it's the converse. It's someone done swap my hypothesis. Let's see. If two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. You guys probably saw that coming. All right, alternate exterior angles converse, which, by the way, I would allow you when writing a proof to abbreviate as such. Okay, so you can done acronymize these things, and I am content with that as an explanation. So let's see, the alternate exterior angles, if I can prove they're congruent, then I know the lines are parallel. Good stuff. Also, apparently, there might be a proof of this tonight. Consecutive interior angles converse. If I have that consecutive interior angles are supplementary, not congruent, then I know that the lines are parallel. Right? Does it seem believable? I hope so. I hope so. So let's do example dose. Example dose. All right, here we go. All right, I've got a little drawing here, and we are asked to prove that the lines are parallel if they're cut by a transversal, as drawn, so that the alternate interior angles are congruent. Okay, all right, here we go. So I know angle 4 is congruent to angle 5. The reason is everybody's favorite, given. I believe I can conclude that angle 1 is congruent. Angle 1 congruent to angle 5. How do you think I can prove that? Well, it doesn't. Oh, sorry. Angle 1 congruent to 4. My bad. My B, friends. My apologies. Sincerest. How do I know angle 1 is congruent to angle 4? Oh, you guys are good at that one now. Vertical angles theorem. Delicious vat of angle measurements. Let's see, now I can say angle 1 is congruent to angle 5. Anyone see it yet? Oh yeah, transitive property. If 1 is congruent to 4 and 4 is congruent to 5, therefore 1 is congruent to 5. It makes sense. That's an explanation, friends. So let's see, transitive property. And is this transitive property of congruence or equality? I'm going to call it congruence because we're dealing with congruence, right? Makes sense. Okay, 1 is congruent to 5. Check this out. I'm going to say that H is parallel to G. What types of angles are 1 and 5? They appear to be acute, but they are in corresponding positions. So by the corresponding angles converse, not the theorem, if corresponding angles are congruent, then the lines are parallel. Question, yes?
Would you say that 4 and 5 are congruent?
Yes, absolutely. From now on, every moment of your life, you can. Because we were attempting to prove that very thing. So we weren't assuming that it was true. I know I already told you it was true, but you had a healthy amount of skepticism and were like, I don't know, I think Mr. Waddy's pulling my leg here. I don't think he's telling the truth. I don't believe anything about these lines being parallel. And as a result, we proved it. And so now you own this, right? This is good stuff. You own this. You believe this. You are bought in. You have proven it, not unlike mathematicians have thousands of years before you. Yes, you are now participating in a long line of mathematician lineage, wonderful stuff, with the rest of humanity coming to the same conclusions they have. I love it. Let's see, in the diagram, R is parallel to S. Oh, nice, they already labeled that for me, thank you. If you ever notice that it's not labeled, label it. Let's just label it. And 1 is congruent to 3. Okay, all right, label it. Prove P is parallel to Q. By the way, on the not quiz tomorrow, there's a question like this where I've got like my tic-tac-toe. Which, by the way, if you were stumped, you should at least do tic-tac-toe on it. Like if you can't do anything else, I can't give you any points for tic-tac-toe, but it would be pretty awesome. Let's see. Oh no. All right, here we go. Also, tic-tac-toe, I think that game's been solved. Like, it's no longer interesting. Oh,
yeah.
Wow, shout out to Tic-Tac-Tony. I don't know what that is, but hopefully it's not inappropriate on the internet or anything. Let's see, so let's prove this. R is parallel to S, given. Let's say angle 1 is congruent to angle 3. Given. I sometimes like to just give all my givens right at the beginning, pick up those easy points, but it sometimes can be valuable to save this for like the reveal, the dramatic reveal later on in the proof when people are like, oh, and just like gasp, like, oh wow, he's doing it, no way. And so you could do that if you wanted. Okay, so let's see. I know R is parallel to S. I'm trying to prove P is parallel to Q. That's my goal. All right. Does anyone see some other information that we could label here? Or other things that I could verify? Let's see. 2 and 1, there's a relationship. What's the relationship? They're congruent. So you're going to say angle 1 is congruent to angle 2. How? They're pals? Man, that was a good sneeze. Good sneeze. Let me tell you a quick little 30-second story for the internet. My best friend and I, we used to exaggerate our sneezes and go, achoo, and just like exaggerate them. And one day, our first job, we were washing dishes at the same place, Westminster Country Club, shout out. And we would then like try to like sneeze in front of each other. So like if your friend was in the other room, you would like have to milk the sneeze to keep it like, so then you'd get to the other room and then be able to go, achoo, and sneeze it all exaggerated. And so one time my friend was doing this and I'm like washing dishes like a pro, of course, because I was getting paid for it. And that is the definition of professional. So he's milking the sneeze and then he like sneezes real big to the side, right when a waitress walked by, and it was not just spray, but like visible mucus, like all over her.
Awesome.
And she was just like so angry.
I have a question.
Yes, question.
If you really want to do a shout out.
A shout out to Westminster Country. Yeah, sure. Shout out to Westminster Country Club. Yeah, that's where I had my first job. I was making money there. So my friend sneezed visible snot all over the waitress. She was real quick to forgive him though. Like I think she kind of liked him, but I don't know. True story. So if you're milking your sneezes and exaggerating them at the end, like you're rolling your R's, be careful who's around you. All right. Moral of the story. Back to the lesson. Let's see. We're saying angle 2 is congruent to angle 1. Why is that? Nope. Starts with a C. Corresponding angles. Theorem, okay? Because I'm working with lines that I already knew are parallel, okay? And I was making a conclusion about angles being congruent, okay? So, I know, hey, wait a minute, you're in the wrong spot, Malik. You done tricked me. All right, I got this. All right. So anyways, I'm concluding the angles are congruent based on the lines being parallel. So that's why I'm using a theorem and not a converse. Now notice, I believe I can say that angle 2 is congruent to angle 3. Anyone spot why? Oh yeah, he's got it with the hand raised. Transitive. Let's see, calling the dogs now. Black Ops. Here we go. We got that kill streak on the transitive property of congruence. Right? Because if 2 is congruent to 1 and 1 is congruent to 3, therefore 2 congruent to 3. Transitive property. Now, notice I've just stated that these two angles are congruent to each other. With respect to lines P and Q, what types of angles are these? They're alternate interior angles that I've just shown are congruent. I believe I can now conclude that P is parallel to Q by the alternate interior angles converse. When you're proving lines parallel, you use the converse. When you're proving angles congruent or supplementary with relationship to this, you use the theorems. Okay, so, all right, question.
If we get that slightly wrong on the test.
Like if you said theorem?
Yeah.
Oh yeah, you'd lose a point. A point. I might throw you half though. Right? So like you get 1 out of 2. Thoughts? How did you know 2 was congruent to 3? Because at this point, I didn't know that these two lines were parallel, right? They could have been all like crooked like what if it was like this? Right? I didn't know, I know that those are alternate interior, but I didn't yet know they were congruent. But once I proved they were congruent, then I was able to conclude that the lines were parallel. All right, and actually now that I've proven the lines are parallel, we should label it. And these would have had double parallel symbols, right? Since they are parallel to each other, but not parallel to the original two. Good. All right. Let's keep going. Ooh, guys, you're going to love this. Oh, man. Here we go. Theorem 3.9. You didn't even know this was possible. Theorem 3.9, transitive property of parallel lines. Look at this. Don't you love this? You love this. Oh, man. Wow. This is amazing. I'm so happy. Aren't you happy that this exists? Wow. If two lines are parallel, all right, to the same line, then they're parallel to each other. Right? Do you believe that? Yeah, it seems to work. Here it's written out, if P is parallel to Q and Q is parallel to R, right? Transitive property. Therefore, P is parallel to R. Thoughts, question, comment? Well, looks like there's going to be some proofs related to this later on. So yeah, so that'll be interesting. So here we go. By the way, like this example 4, the last example, before we get to our class quest, is similar to some other problems that the book gives as well, where where's my scroll bar? There it is. There we go. Like, look at this. Wow. How patriotic of this problem, of this book. Although they do have other nations' flags represented in the problem set that I could have selected for the quiz. Yeah. But here we go. Ladies and gentlemen, the flag of the United States has 13 alternating red and white stripes. So question, is it a white flag with red stripes or a red flag with white stripes?
Red and white.
Well, it's not equal, though. It's an odd number.
I don't know.
Looks like it's mostly red. It starts with red and
Why they say red, white?
red, white, and then blue. So in terms of area, does red have the greatest area and then white and then blue? Although white might have the most area, consider this, because even though it's got one less stripe, does the sum of the areas of all of these little stars add up to more than that remaining red stripe? And also notice this red stripe is only like a 2/3 full stripe. I don't know. Yeah. Someone's going to go find the area of all of these stars and compare the areas of white to red to blue. Wow. Well, anyways, we have no need to divide our nation over such a significant geometric issue as this. We can all agree that geometry is the most important thing to all of us. And therefore, we'll just move forward with this problem as intended. It says each stripe is parallel to the stripe immediately below it. I believe it. Okay. Explain why the top stripe is parallel to the bottom stripe. What's it called? The transit, right? The thing that I just showed you. Wow. The transitive property. I'll need to edit in like our national anthem over this as I slowly write this out. Transitive property. Guys, sometimes I do wish life was more just like High School Musical 3. But anyways, thanks for watching, internet friends. Remember, go out and rent High School Musical 3 from Redbox and go enjoy a meal or a round of golf at the Westminster Country Club. Have a great day, friends. Bye-bye.